MedRundowns 2, Basal Ganglia. Ladies and gentlemen, welcome to this mini lecture on the basal ganglia, a fascinating group of structures in the brain that play a vital role in the regulation of movement and various other aspects of behavior. The basal ganglia consist of several key components, including the striatum, pallidum, and lenticular nucleus. The subthalamic nucleus and substantia nigra are also important components. Let's delve into each of these structures and their functions. First, we have the striatum, which is composed of two parts, the caudate nucleus and the putamen. The striatum receives input from various regions of the cerebral cortex and is involved in the initiation and execution of voluntary movements. It plays a crucial role in the coordination of motor activity and the fine-tuning of motor output. Moving on to the pallidum, this structure consists of the pale parts, the globus pallidus. This is then divided into two parts, the globus pallidus externus, GPE, and the globus pallidus internus, GPI. The GPE primarily inhibits movement, acting as a brake, while the GPI plays a crucial role in controlling movement. It sends signals to regions of the thalamus, which, in turn, sends signals to the motor cortex, ultimately influencing motor output. Now, let's focus on the lenticular nucleus. This nucleus is comprised of the putamen and the GPI. The putamen, as part of the striatum, contributes to motor control and the regulation of movement. The GPI, on the other hand, plays a role in modulating motor activity and coordinating movement through its connections with other brain regions. It's important to note that the basal ganglia aren't solely involved in motor circuits. They also have associative circuits and limbic circuits, which are essential for the processing and integration of sensory, motor, and cognitive information from different regions of the brain. These circuits enable us to link sensory input with motor output and play a role in cognitive functions, such as attention, decision-making, and learning. Furthermore, the basal ganglia have implications beyond movement and cognition. They are also involved in emotions and moods through their connections with limbic regions of the brain. This integration between motor, cognitive, and emotional processes highlights the complexity and versatility of the basal ganglia. Lastly, it's worth mentioning that dysfunctions in the basal ganglia can lead to movement disorders, such as Parkinson's disease, Huntington's disease, and hemibolismus. In Parkinson's disease, there is a depletion of dopamine in the basal ganglia, resulting in motor impairments such as tremors, rigidity, and bradykinesia. Huntington's disease, on the other hand, is characterized by the degeneration of certain neurons within the basal ganglia, leading to involuntary movements and cognitive decline. In conclusion, the basal ganglia encompass the striatum, pallidum, lenticular nucleus, STN, and substantia nigra, which collectively contribute to the regulation of movement and various aspects of behavior. They form intricate circuits involved in motor control, sensory integration, cognition, and emotions. Understanding the functions and dysfunctions of the basal ganglia is crucial for unraveling the complexities of the brain and its impact on our daily lives.